press the bell icon on the YouTube app and never miss another update.
Hello students, today topic is types of halides which are belongs to 15th A group elements. Halides, 15th A group elements: nitrogen, phosphorus, arsenic, antimony, bismuth. Nitrogen, phosphorus, arsenic, antimony, bismuth are denoted by the letter is E. We know that general electronic configuration is NS2, NP3. Removal of 3 electrons from outermost. The oxidation state of 15th A group element is +3. Removal of 2 more electrons from s orbital, then total number of electrons 3 plus 2 is equals to 5. Again these group elements oxidation state is +5. +3 oxidation state, removal of 3 electrons from p orbital. +5 oxidation state, removal of 3 electrons from p orbital and 2 electrons from s orbital. So E is nitrogen, phosphorus, arsenic, antimony, bismuth and halogens. We know halogens: fluorine, chlorine, bromine, iodine. These are 17th A group elements or 7th A group elements. General electronic configuration is NS2 NP5. For octet configuration, these group elements required 1 electron. So general oxidation state of halogens -1, +1, +3, +5, +7. But for octet configuration we consider 1 electron required for octet. Fluorine required 1 electron, chlorine, bromine, iodine. These elements required 1 electron for octet configuration. So each halogen required for one unpaired electron for octet. So here nitrogen general oxidation state +3 and +5. So according to this oxidation states, nitrogen, phosphorus, arsenic, antimony, bismuth are denoted by the letter E, and this particular E is available in 3 oxidation state and E is available in 5 oxidation state, +3 oxidation state and +5 oxidation state. And we know that halogens are denoted by X. X oxidation state is 1. Here also X oxidation state is 1. Then crisscross method. Crisscross. What will be the formula? EX3. EX3. EX3 is the formula of 15th A group elements. This formula is said to be trihalide. It is called as trihalide. While going to the second example, crisscross method, interchange the valencies, then the product is EX5 EX5 is called as pentahalide. Because of for competitive point of view, this topic was very important. We expect a question for NEET point of view or JEE point of view. We should revise this chemical reactions, trihalides, pentahalides, general formula trihalides EX3, pentahalides general formula EX5. What is E stands for? 15th A group element, nitrogen, phosphorus, arsenic, antimony, bismuth, and halogens are denoted by X. X is nothing but fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine are called as halogens. So here two types of halides, EX3 halides, EX5 halides. Let us discuss about this type of halides. So here let us discuss the importance. Let us discuss the importance of this type of halides. Type 1 EX3, type 2 EX5. Some important points regarding this types of halides. EX3, central atom E. Central atom E is nothing but 15th A group element. X is halogen. EX3. EX3, point number 1, all EX3 type halides are sp3 hybridized. Make a note, this was very important for competitive point of view. EX3 type halides, sp3 hybridization. And second one is shape of the molecule is pyramidal. EX3 type halide shape was pyramidal shape. Central atom E undergoes sp3 hybridization. And third one is number of bond pairs, 3 bond pairs, and number of lone pairs, 1 lone pair, 3 bond pairs plus 1 lone pair. And what are the examples? If you consider E is equals to nitrogen, X is equals to Cl, then the example is NCl3, nitrogen trichloride, PCl3, phosphorus trichloride, AsCl3, arsenic trichloride. Remember students, trihalides, all trihalides are sp3 hybridized. Trihalides are pyramidal shape with 3 bond pairs plus 1 lone pair. Examples NCl3, PCl3, AsCl3. While coming to the pentahalides, all pentahalides are sp3 dehybridization. All pentahalides are sp3 dehybridization, and the shape of the molecule is a trigonal bipyramidal. Trigonal bipyramidal. This was the shape of pentahalides. Trigonal bipyramidal. 5 bond pairs plus 0 lone pairs. 5 bond pairs plus 0 lone pairs. So this was one of the important topic regarding a competitive point of view. EX5, what is E? E is 15th A group element. Suppose E is equals to N, X is equals to Cl, then what will be the compound is NCl5. NCl5 is called as nitrogen pentachloride. Nitrogen pentachloride does not exist. Does not exist. Nitrogen pentachloride does not exist. Or whatever the element present in this, in the place of chlorine, fluorine, bromine, iodine, NX5. Instead of that, you make a note, it is NX5. NX5 means nitrogen does not form pentahalides. Nitrogen does not form pentahalides. This is question number 1 for board examination point of view. Why nitrogen does not form pentahalides? Why nitrogen does not form pentahalides? What will be the reason? Reason is Nitrogen electronic configuration, we know that electronic configuration of nitrogen 2s2, 2p3, there is no presence of 2d is absence in second orbit. Second orbit only subshells, two subshells, one is s orbital, second one is p orbital. There is no presence of 2d orbital. So here, due to the absence of vacant d orbitals, very important theory point of view question it is. Make a note, students, make a note. Why dinitrogen does not form pentahalides? NCl5 not exist, PCl5 exist. Question will be like this only. PCl5 exist while NCl5 does not exist. What the reason? NCl5 does not exist. Why NCl5 does not exist? N doesn't have vacant d orbitals. Nitrogen doesn't have vacant d orbitals. If vacant d orbitals are there, then electron splitting takes place. Further, it is ready to form 5 bonds. Already we discussed in earlier class, nitrogen covalency is 4 only. Nitrogen form maximum 4 bonds, minimum 3 bonds. 3 bonds nitrogen is stable. Maximum, due to the presence of one lone pair of electron, nitrogen maximum bonds are 4. So covalency of nitrogen is 4 only. Nitrogen does not form pentahalides. What is the reason? Nitrogen does not form pentahalides. Reason is nitrogen atom doesn't have vacant d orbitals. Due to the absence of vacant d orbitals, nitrogen cannot form pentahalides. Except nitrogen, remaining all pentahalides are followed sp3d hybridization, trigonal bipyramidal shape with 5 bond pairs plus 0 lone pair. What are the examples? Examples we consider, that is PCl5, phosphorus pentachloride, ASCl5, arsenic ASCl5, arsenic pentachloride, SbCl5 and BiF5. Make a note for this also, BiCl5 not exist. BiCl5 does not exist. Why BiCl5 does not exist? Already we know that in p block elements, down the group means from nitrogen to bismuth. Already we know these group elements oxidation state +3 and +5. While coming to nitrogen to bismuth down the group, the stability of +3 oxidation state increases, stability of +5 oxidation state decreases. Due to the reason is, already we know that what is the reason it is? Inert pair effect. Make a note, this is very important. Due to the inert pair effect, BiCl5 not exist, BiF5 exist. BiF5 exists, again further it decomposes to BiF3 only. BiF5 exists, but later it decomposes to BiF3. So make a note, this will be the general information regarding halides. Nitrogen are 15th A group elements. 15th A group elements form 2 types of halides: trihalides, molecular formula EX3, pentahalides, molecular formula EX5. All trihalides are sp3 hybridized. All pentahalides are sp3d hybridized. All trihalides are pyramidal shape with 3 bond pairs plus 1 lone pair. All pentahalides are trigonal bipyramidal shape with 5 bond pairs plus 0 lone pair. Exception is what? Nitrogen does not form pentahalide. This is important board examination point of view question. Make a note, revise this question. Why nitrogen does not form pentahalides? Because of the reason is nitrogen atom doesn't have vacant d orbitals. Due to the absence of d orbitals, nitrogen does not form pentahalides. Nitrogen only form trihalides. So here, and bismuth only, again we coming down to bismuth, down the group, the stable oxidation state decreases by 2 units with respect to the group number. Due to that reason, that is explained in the form of inert pair effect. Due to that inert pair effect, bismuth does not give pentachloride, bismuth give only pentafluoride. That particular pentafluoride further decomposes to trifluoride only. So this will be the simple information regarding halides, and here we make a note for competitive point of view. Some questions we expect from this, some competitive point. competitive point of view, some questions we expect from this halides, trihalides and pentahalides. And here you remember one more point, we know that PCl5 is called as phosphorus pentachloride. Phosphorus pentachloride, this is in gaseous state, phosphorus available pentaform, that is pentachloride. Suppose if it is in solid state, this is very important competitive point of view question it is. Suppose PCl5 in solid, if it is solid, PCl5 solid, PCl5, this formula is applied when PCl5 is in gaseous state. Suppose PCl5 is in solid, how this molecular formula exists means, this molecular formula exists as PCl4 plus and PCl6 minus. This is complex formation PCl4 plus and PCl6 minus. Similarly, PBr3, PI3 also available in the solid form like this type of structures only. So remember, this is very important competitive point of view question. In gaseous state, phosphorus pentachloride formula is PCl5. In gaseous state it is PCl5. Once we discuss about the solid state, what is solid? PCl5 solid configuration. Solid configuration of phosphorus pentachloride, PCl4 plus PCl6 minus. This 4 stands for 4 bond pairs, 6 stands for 6 number. So it is sp3 hybridized and it is sp3d2 hybridized. One is a tetrahedral geometry and second one is octahedral geometry. So remember, this is one of the important competitive point of view question. In gaseous state, phosphorus pentachloride formula PCl5. In solid state, phosphorus pentachloride exists in PCl4 plus and PCl6 minus. And next one, very important reactions, that is hydrolysis. Hydrolysis of halides. Hydrolysis means addition of water. Addition of water to halides. Already we know that two types of halides are there, EX3 trihalides, EX5 pentahalides. So what will be the condition? Condition for hydrolysis. What the condition for hydrolysis? For hydrolysis condition. So you have to remember this condition. What are the conditions? Means must and should. Must or at least required vacant orbital. At least or must and should or compulsory. So what we require? Compulsory we required vacant orbital. If vacant orbital is present, hydrolysis reaction takes place. If vacant orbitals are absent, there is no hydrolysis. So remember here, this is one and only important condition. If substance which contains vacant orbitals, the particular substance undergoes hydrolysis. So here, according to this condition, suppose the example is, we are going to 13th A group, suppose 13th A group, the general example is BCl3, suppose BCl3 is called as boron trichloride hydrolysis. Hydrolysis of boron trichloride. What is boron electronic configuration? Boron atomic number 5, the configuration is 1s2 2s2 2p1, 2s 2 electrons, 2p 1 electron. This electron configuration is called as ground state electronic configuration. Ground state electronic configuration of boron atom. Only one unpaired electron is present. Only one unpaired electron is present in boron atom. Then this pairing electron is also there, and already we know here there is no presence of 2d orbital. Is it possible for 2d? 2d orbital is impossible. So here only 2p1. Then splitting. If this pairing electron required sufficient energy, then what the electronic configuration we will get, that is 2s1 2p2. This electron configuration is called as First excited state electronic configuration. First excited state electronic configuration of boron atom contains one vacant orbital. So this boron is ready to react with water. Then boron trichloride on hydrolysis. Boron trichloride on hydrolysis because of oxygen in water molecule. In water molecule, oxygen atom contains two lone pair of electrons. This particular lone pair required one vacant orbital. Lone pair required vacant orbital. Due to that reason, hydrolysis reaction takes place in the presence of vacant orbitals. So here vacant orbital is present in this example. So boron vacant orbital is 2p vacant orbital. Then what the product we expect from this? BCl3 plus H2O gives rise to the compound is H3BO3. H3BO3 is called as boric acid, orthoboric acid. H3BO3 and formation of what it is? HCl. So this is a simple equation, hydrolysis reaction of 13th A group element. Why we discussed 13th A group element hydrolysis reaction instead of hydrolysis of halides? Which halides? Hydrolysis of which halides here? 15th A group elements halides hydrolysis reactions we have to discuss. Instead of that, why we discuss this one? Because generally hydrolysis reactions are followed like this only. General reaction this is. General means BCl3 plus H2O gives rise to H3BO3 plus HCl. H3BO3 plus HCl, this is orthoboric acid. Orthoboric acid, weak acid this is. And here sometimes we should write this formula is like this also. So don't get confused. BOH taken thrice. BOH taken thrice. H3BO3. H3BO3. See this H3BO3, BOH taken thrice. Don't confuse. When OH functional group is there, this particular OH group is base. So don't get confused like that. H3BO3 can be written as BOH taken thrice. So this is an example for acid. This is an example for acid. So here BCl3 on hydrolysis gives rise to H3BO3. H3BO3 can be written as BOH taken thrice. This reaction, how this reaction takes place? Due to the presence of vacant orbitals. For hydrolysis reactions, we require vacant orbitals. This will be the basic fundamental rule. According to this rule only, we have to find the answer. And one more information is there regarding this. In boron trichloride, oxidation state of boron is +3. Boron oxidation state +3. While coming to the product also, oxygen oxidation state -2. -2 into 3 -6. -6 hydrogen oxidation state +1. +1 into 3 +3. Here -6, here +3. Then what we required for neutralization? We required again +3. So here what is oxidation state of reactant non-metal boron is +3. Product boron also +3. So compound, what the compound we expect from this reaction according to the oxidation number? What the oxidation involving in this equation? Same oxidation number product we will get. Suppose here it is +5. Then what will be the answer is? Answer is +5 answer only. According to the oxidation number concept also we have to find the answer. So BCl3 combines with water gives rise to H3BO3. In H3BO3 oxidation number of boron is +3. In BCl3 oxidation number of boron is +3. So here +3, here +3. Same reaction you applied to PCl3. PCl3, we know that what is PCl3? PCl3 is called as phosphorus trichloride. PCl3 phosphorus trichloride. Already we know that phosphorus configuration 15 configuration 1s2, 2s2, 2p6 followed by 3s2, 3p3. 3 unpaired electrons are present in p orbital, pairing electron present in s orbital, and we know that here what it is? Vacant d orbital is present. Vacant d orbital is present in this example. So this electronic configuration is called as ground state electronic configuration, and in this ground state electronic configuration 3 unpaired electrons are present. Already we know that here d orbitals takes place. So this compound easily undergoes hydrolysis. Then you should add water to this addition of water to this, addition of water to BCl3, addition of water to BCl3, what the compound is? BOH taken thrice. BOH taken thrice is called as boric acid. Same, repeat the formula. Here instead of boron, here the element is phosphorus. Then what will be the compound is? POH taken 3 plus HCl. What is POH taken 3? POH taken 3 can be written as, don't get confused, it is not a base, this is acid, so it is H3PO3. H3PO3 is known as orthophosphorus acid. So remember here H3PO3. H3PO3 can be written as POH taken thrice. POH taken thrice or H3PO3. This reaction, this compound is called as orthophosphorus acid, and here H3PO3 is boric acid, orthoboric acid. So here same, that's why we discussed this equation. General halides, general trihalides. Suppose if you consider ASCl3, ASCl3 plus H2O gives rise to what is the compound is? ASOH taken thrice. What is ASOH taken thrice? ASOH taken thrice can be written as H3ASO3. H3ASO3. Remember in 15th A group elements, phosphorus, arsenic. Phosphorus and arsenic on hydrolysis gives rise to us acids. Us acids means phosphorus acid, orthophosphorus acid. What the general reaction takes place on hydrolysis of halides. Same reaction followed with respect to phosphorus and arsenic, which are present in 15th A group elements. Except phosphorus and arsenic, remaining 3 elements will be there in the 15th A group elements, that is nitrogen, antimony, bismuth. Let us discuss the hydrolysis of nitrogen, antimony, bismuth. What the products we expect from that reactants, and what are the products, and that reactions takes place in which pattern. So general pattern is BOH taken thrice or POH taken thrice or ASOH taken thrice. Trihalides on hydrolysis gives rise to us acids. Us acids can be applied for the 15th A group elements. Suppose if you would like to go to 13th A group element, the answer is boric acid. And here suppose the compound is NCl3. NCl3 plus H2O. Nitrogen configuration, atomic number 7, 1s2, 2s2, 2p3, 2d0 not present, 3 electrons present in p orbital, 2 electrons present in s orbital, 2 electrons present in 1s orbital. See this electronic configuration of nitrogen atom. Nitrogen atom electronic configuration, 2 electrons are present in s orbital, 3 unpaired electrons are present in p orbital. Then what the reaction? Hydrolysis of halides. NCl3 is dissolved in water or combined with water. Nitrogen trichloride combined with water. What the condition for hydrolysis reaction? Condition is presence of vacant orbitals. Vacant orbital is present in nitrogen atom. Is it right or wrong? Vacant orbital is present in nitrogen atom. Yes or no? No. Because of nitrogen atom 2s completely filled, 2p half filled configuration. Is it possible for 2d? There is no possible for 2d. Then nitrogen atom is ready to undergo hydrolysis reaction? No. But nitrogen is combined with chlorine. Nitrogen is combined with chlorine. Once you remember, for hydrolysis reaction, already I said that lone pair is present on oxygen atom. Oxygen lone pair required vacant orbitals. Oxygen atom lone pair required vacant orbitals. So based on this, we have to explain the hydrolysis reaction while going to the chlorine atomic number 17. Neon 3s2 2 electrons in s orbital, 3p5 5 electrons in p orbital, and followed by 3d0. So here nitrogen atom doesn't have vacant orbitals, but chlorine vacant d orbitals are there. Chlorine atom is ready to give accommodation for lone pair of electrons which are present on oxygen atom. Due to this reason, previous we discussed regarding boron. Boron itself has vacant orbital. Then the product is BOH taken 3. Boron itself has vacant orbital, then the product is BOH3. But nitrogen atom doesn't have vacant orbital. But chlorine configuration, here d orbitals are available. Due to the availability of d orbital, the product will be different product we expect from this. This will be the very important for competitive point of view. Make a note for competitive point of view. NCl3 plus water. Instead of NCl3, suppose it is PCl3, ASCl3, BCl3. Reaction occurs generally what the products we expect according to the reaction followed like that only. But here instead of that examples, the compound is NCl3. Nitrogen doesn't have vacant d orbitals, but chlorine vacant orbitals are there. Due to the presence of vacant orbitals in chlorine atom, this particular compound undergoes hydrolysis, gives rise to the compound is NH3 plus HOCl. Very important reaction it is. Nitrogen trichloride, addition of water to nitrogen trichloride. What will be the compound is? Compound is ammonia. It liberates ammonia. Suppose it is phosphorus trichloride, what will be the answer is? Answer is orthophosphorus acid, H3PO3 we will get. If it is boron trichloride, answer is H3BO3, boric acid. So make a note students, this was very important reaction. NCl3 on hydrolysis gives rise to NH3 plus HOCl. NCl3 on hydrolysis gives rise to NH3 plus HOCl. While coming to the one more example, that is SbCl3 and BiCl3. On hydrolysis of SbCl3, BiCl3, and here SbCl3 plus H2O gives rise to, remember this is SbOCl plus HCl. SbOCl, HOCl, hypochlorous. Removal of H from this compound is called as hypochlorite. This is called as OCl minus HOCl is called as hypochlorous acid. Removal of H from this, the remaining part ClO minus is called as hypochlorite. Same pattern SbCl3. In SbCl3 already you know that presence of d orbitals, vacant d orbitals takes place in this example, but the product is not followed as PCl3 hydrolysis. ASCl3 hydrolysis, BCl3 hydrolysis are followed general trend. But here SbCl3, once the compound is SbCl3, the answer will be SbOCl plus HCl. Hypochlorite, stibbium hypochlorite is a compound. Very important point it is. And one more example is also there, BiCl3 plus H2O gives rise to BiOCl plus HCl. So make a note, these are the very important reactions. Hydrolysis of trihalides, except nitrogen, antimony, bismuth, remaining phosphorus trichloride or phosphorus trihalide, arsenic trihalide, hydrolysis reactions are followed in general pattern. Due to the absence of vacant d orbitals in nitrogen atom and due to the presence of vacant d orbitals in chlorine atom, the hydrolysis of NCl3 is followed in different pattern, and due to the inert pair effect and down the group plus 3 oxidation state increases for heavy elements. Due to that reason, the compounds what we expect from SbCl3 and BiCl3 will be SbOCl and BiOCl. SbCl3 gives rise to SbOCl, BiCl3 gives rise to BiOCl. So, this will be the information regarding hydrolysis of trihalides. And one more question also there in this example. So, once again, you should remember these equations. All equations are not followed in general manner or general pattern. Some equations are followed in different style or different pattern. So, what the equations we discussed? BCl3 plus H2O gives rise to answer is BOH taken 3 plus HCl. If it is PCl3 plus H2O gives rise to POH taken 3 plus HCl. If the compound is AsCl3 plus H2O gives rise to ASOH taken 3 plus HCl. This is general pattern, general hydrolysis reaction. What is the importance of NCl3? NCl3 plus H2O gives rise to NH3 plus HOCl. SbCl3 plus H2O gives rise to SbOCl plus HCl. BiCl3 plus H2O gives rise to BiOCl plus HCl. While coming to the, this is the second pattern. While coming to the one more example is that CCl4 plus H2O gives rise to this is very important point. So dear students, give a look for this reaction. NCl3 on hydrolysis liberate NH3. While coming to the CCl4, CCl4 is carbon tetrachloride hydrolysis. Hydrolysis of carbon tetrachloride, there is no reaction. Why? What is the reason? Why NCl3 on hydrolysis to produce NH3? CCl4, there is no product. What will be the reason? Already carbon, we know that configuration of carbon electron configuration 2s2 2p2, 2s2 2p2, 2 electrons present in s orbital, 2 electrons present in p orbital. This is ground state electronic configuration. While going to the excited state configuration 2s1 and 2p3, here condition 1 satisfied. Nitrogen doesn't have d orbitals. Similarly, carbon atom also doesn't have d orbitals. But nitrogen is combined with chlorine. We know that chlorine vacant d orbitals are there. Here also chlorine atom is there. In this chlorine atom vacant d orbitals are there. This chlorine atom not accommodate electron pair which is coming from oxygen atom. Due to that reason, this reaction not takes place. What will be the reason? Reason only you have to notice this reason. The reason can be explained in the form of electronegativity values. Electronegativity of nitrogen and chlorine will be similar. Electronegativity of nitrogen and chlorine will be similar means nitrogen electronegativity 3.04, while coming to the chlorine electronegativity 3.16. And here, what will be the electronegativity of carbon and chlorine? Carbon electronegativity 2.5, chlorine electronegativity more. The electronegativity gap between carbon and chlorine is much more compared to electronegativity gap between nitrogen and chlorine. In this example, both nitrogen and chlorine both are having same type of charge. Same charge means there is no special. There is no special means chlorine is not special for nitrogen. Nitrogen is not special for chlorine. But in this example, CCl4, chlorine is special. Why chlorine is special means chlorine electronegativity value is more than carbon. Chlorine electronegativity value more than carbon, then chlorine occurs negative charge, carbon is positive charge. Attacking species oxygen lone pair also negative, negative versus negative repulsions takes place. Due to the repulsions, the lone pair is not easily accommodate on chlorine vacant orbitals. Due to that reason, due to the absence of vacant orbitals in carbon, that is reason 1. Why CCl4 does not undergo hydrolysis means due to the absence of vacant d orbitals in carbon, but presence of vacant d orbitals in chlorine, but chlorine electronegativity value more than carbon. Due to that reason, incoming attacking species oxygen lone pair of electron is also negatively charged, chlorine also negatively charged, negative versus negative repulsions takes place. Then why it accommodates the lone pair in d orbital? Due to that reason, CCl4 does not undergo hydrolysis. NCl3 critical condition it undergoes hydrolysis, and the product is different, that is ammonia. So make a note, this is very important competitive point of view question. So CCl4 does not undergo hydrolysis, NCl3 hydrolysis gives rise to ammonia, NCl3 hydrolysis gives rise to ammonia, CCl4 not hydrolyzed. What is the reason for CCl4 not hydrolyzed? CCl4 not hydrolyzed means C doesn't have vacant d orbitals. Okay, satisfied. What is condition 2? Cl has vacant d orbitals, but CCl electronegativity values, Cl more electronegative than C, then is it not possible to accommodate the lone pair in vacant d orbital? Due to that reason, CCl4 not gives hydrolysis reaction. So this will be the chemical reactions of trihalides. Suppose if the compound is pentahalide, if the compound is pentahalide, means already we know that NCl3, NCl3 exist, NCl5 not exist. What is the reason? Reason is due to the absence of vacant d orbitals. Second one, PCl5, here PCl3. PCl3 gives rise to, the answer is H3PO3. H3PO3 is we know that the compound is phosphorus acid. Reactants oxidation state of phosphorus plus 3. In products oxidation state of phosphorus plus 3. 3 to the 6, 6 minus 3 plus 3. Here also 3 minus means 3 plus. Plus 3 oxidation reactant gives rise to plus 3 oxidation number product. So this compound is called as phosphorus acid. If the compound is PCl5, hydrolysis of PCl5 gives rise to, in PCl5 oxidation number of phosphorus plus 5, and the compound is H3PO4. H3PO4 oxidation number of phosphorus plus 5. This compound is called as phosphoric acid. Phosphoric acid. So here phosphoric acid, phosphorus acid. We know two types of phosphorus acids are there. One is a phosphorus, second one is phosphoric. Phosphoric oxidation number of phosphorus plus 5, phosphorus oxidation number of phosphorus plus 3. So this is hydrolysis of pentahalide reaction. It is hydrolysis of trihalide reactions. Trihalides of 15th group elements produce acids except nitrogen, antimony, bismuth, and pentahalides on hydrolysis gives rise to ic acids. If the example is phosphorus, phosphorus acid and phosphoric acid. So these are the types of halides and their hydrolysis reactions. Make a note regarding the competitive point of view. NCl3 on hydrolysis liberate ammonia gas. CCl4 does not undergo hydrolysis. CCl4 does not undergo hydrolysis. What will be the reason? Due to the absence of vacant d orbitals in carbon atom. And NCl3 undergoes hydrolysis. NCl3 also belongs to like that, but chlorine atom does that. Chlorine atom contains vacant d orbitals. Due to that reason, it undergoes hydrolysis reaction. So suppose the example is phosphorus, phosphorus trichloride H3PO3, arsenic trichloride H3ASO3. If it is boron trichloride H3BO3. If it is carbon tetrachloride, there is no answer, because of for carbon tetrachloride not undergoes hydrolysis reaction. So this is about halides, and after this halides and this 15th A group elements are reacts with metals to form nitrides. So reacts with metals to form nitrides, that is called as metals versus 15th A group. So that is called as metal nitrides. Metal nitrides, example Li3n, Li3n available, Li plus N2. Li plus N2 gives rise to Li3n, 6Li plus N2 gives rise to Li3n, and Mg 3 plus N2 gives rise to Mg3n2. So these are the examples for nitrides. So 15th group elements combines with metals to gives metal nitrides. Suppose Ca calcium, P phosphorus. So what will be the answer is Ca3P2. Ca3P2 means calcium phosphide. Suppose it is Zn plus phosphorus, answer is Zn3P2. If it is sodium and it is arsenic, what will be the answer is Na3As. Lithium nitride, magnesium nitride, calcium phosphide, zinc phosphide, sodium arsenide. These are the examples with respect to the 15th A group element. Already we know that nitrogen diatomic, phosphorus arsenic are tetraatomics. While writing chemical equations, we followed P4, AS4, SB4 only, not P2, P like that. So this will be the examples related to nitrides. So these are the general properties, general characteristics of 15th A group elements. So 15th A group elements form hydrides and oxides and halides and metal nitrides. Hydrides, oxides, halides, metal nitrides. And after this, next one is important for board examination, and one question is important for competitive point of view. So give a look for this. That is, next topic is dinitrogen. So dinitrogen molecular formula N2, dinitrogen molecular formula N2, nitrogen electronic configuration 1s2, 2s2, 2p3, 5 electrons are present in outermost electronic configuration. For octet it required 3 electrons. For octet it required 3 electrons. So these are 5 electrons which are present in outermost. These are 5 electrons which are present in outermost, and formation of which bond takes place between 2 nitrogen atoms. Triple bond takes place. 2 nitrogen atoms, triple bond takes place. In this triple bond, one is sigma bond, remaining 2 are the pi bonds. One is sigma and remaining 2 are the pi bonds. So here make a note regarding this dinitrogen molecular formula N2. Between 2 nitrogens, which bond takes place? Between 2 nitrogen atoms, triple bond takes place. The triple bond, one is sigma bond, remaining 2 are the pi bonds. And here bond order. What is bond order? Bond order of dinitrogen is 3, and dinitrogen is an example for which substance? Diamagnetic substance. Dinitrogen is an example for diamagnetic substance. Between 2 nitrogen atoms, triple bond takes place. On the triple bond, one is sigma bond, remaining 2 are the pi bonds, partial overlapping, and it contains one lone pair, and bond order is 3, and this particular compound is an example for diamagnetic substance. And this dinitrogen is available in atmospheric air by 78% by volume. It is 78% by volume it is available in atmospheric air, and in solid state also in earth crust it is available in 0.0002%. 0.0002% solid form is available in earth crust, and in atmospheric air 78% by volume it is available, and this particular nitrogen is also available in the form of salts. Those salts are called as saltpeters, Chile saltpeter and Indian saltpeter. The molecular formula of saltpeters are NaNO3 and KNO3. Already we know that NO3 is called as nitrate, NO2 is known as nitrite. Make a difference between that two. So here make a systematic notes regarding this, because of it is very important for board examination. In atmospheric air it is available by 78% volume, and dinitrogen is available in saltpeter, that is NaNO3 and KNO3. NaNO3 Chile saltpeter, KNO3 Indian saltpeter, and by atmospheric air it is available in 78%, and in earth crust it is available in solid state. It is what 0.002%. 0.002% is available in solid state, and this dinitrogen is very important points are there regarding this dinitrogen. This particular dinitrogen is odorless, colorless, tasteless, non-toxic and inert with respect to chemical reactions. Remember students, these are the simple physical properties of dinitrogen. Dinitrogen gas is odorless. Dinitrogen or nitrogen, there is no difference between dinitrogen and nitrogen, both are same. Molecular formula N2, linear structure it is. It is odorless, colorless, tasteless, non-toxic and inert with respect to what? Chemical reactions. Why dinitrogen inert? Why dinitrogen inert? Because of what is the reason? N triple bond N. This only the reason. Between two nitrogen atoms triple bond takes place. Between two nitrogen atoms triple bond takes place. One is sigma bond, remaining two are the pi bonds. And to break this bond, to break the bond we require some energy, that is 225 kilocalorie per mole. 225 kilocalorie per mole or 941.4 kilojoule per mole energy we required to break the bond. Very high energy required to break this bond. 225 kilocalorie per mole or 941.4 kilojoule per mole. High energy required to break this bond. Once bond break or bond cleavage takes place, then this molecule is converted into atomic nitrogen. That atomic nitrogen is more reactive towards chemical reactions. Due to that reason, it is inert. Dinitrogen is inert at room temperature. So, when we expect chemical reactions for dinitrogen, we require temperature. If you supply temperature, that particular temperature, then this bond cleavage takes place, then nitrogen undergoes or nitrogen participate chemical reactions. So, the bond break energy 225 kilocalories per mole or 941.4 kilojoules per mole, very high energy. If you supply this amount of energy, then bond cleavage takes place. So, dinitrogen is inert, dinitrogen is not toxic, dinitrogen tasteless, colorless, odorless. By atmospheric air it is available 78% by volume free state, and it is also available in the form of saltpeter compounds, that is NaNO3 and KNO3, and in earth crust it is available in the form of solid state 0.002%. And this dinitrogen, what are the preparations? Very important point. Preparations of dinitrogen. How to prepare dinitrogen? How to remember the equations? For competitive point of view, how to revise these equations? This is very important. How to revise this equation? Dinitrogen. Already we know that it is available in the form of nitrate. So here, how to revise, how to remember the equations for competitive point of view. So here number 1, from, not number 1, it is the process is thermal decomposition. Thermal decomposition. Thermal decomposition of what? What we have to revise? If you found thermal decomposition, what will be the product? How we expect product from particular reactants? So, make a note regarding this thermal decomposition. Number 1 is from ammonium nitrite. Make a note, students, this is very important reaction. From ammonium nitrite. Molecular formula of ammonium nitrite is NH4NO2. Ammonium nitrite molecular formula NH4NO2. Thermal decomposition means you supply some external energy or heat the substance. While where you observe like this heating reaction means fix one point in your mind, that is removal of water. Maximum water molecules you should remove from this formula. Maximum water molecules. How many water molecules will be eliminated from this equation? You have to follow that only. That is only called as thermal decomposition. Thermal decomposition means our target is water removal of water from reactants. How many water molecules you should remove? According to the formula, you should remove the number of water molecules. Here, how many hydrogens? 4 hydrogens. How many oxygens? 2 oxygens. Water molecular formula H2O. 2 hydrogens required, 1 oxygen. 4 hydrogens required, 2 oxygens. So, first you should remove 2 water molecules. Remove 2 water molecules, 2 to the 4 hydrogens, 2 oxygens. 4 hydrogens, 2 oxygens will be removed. What will be the remaining part is? Remaining part is this only. 2 nitrogen atoms. 2 nitrogen atoms can be written as N2 gas, dinitrogen. Very important reaction. This is thermal decomposition of ammonium nitrite. Remember, this is ite and some more compounds also there, that is nitrate. So, thermal decomposition of ammonium nitrite. Thermal decomposition of ammonium nitrite gives rise to which gas it is? Dinitrogen gas. On elimination of water molecule. Our target is removal of water. Remove water from this particular equation. Remove the water. Once remove the water, NH4NO2, removal of water gives rise to N2 plus 2H2O. Suppose one more equation is there. One more equation, second one is from ammonium dichromate. Ammonium dichromate formula NH4 taken twice, Cr2O7. Again they should give like this thermal decomposition equation. Thermal decomposition means removal of water. Our target is removal of water. How many hydrogens are there in this formula? Total number of hydrogens 4 to the 8 hydrogens. And how many oxygens? 7 oxygens. 8 hydrogens, 2 hydrogens required, 1 oxygen. 2 hydrogens required, 1 oxygen. 8 hydrogens required, 4 oxygens. So first you eliminate how many water molecules? 4 water molecules from that. 8 hydrogens will be eliminated, 4 water molecules will be eliminated, 7 oxygen atoms are there, 7 oxygen atoms minus 4 oxygen atoms. Because here 4 oxygen atoms will be lost and here minus 4, remaining will be 3 oxygens with 2 chromiums, that is Cr2O3. And what is the last compound is how many nitrogens? 2 nitrogen atoms will be there, so it is N2 gas. So remember, this is also very important equation. thermal decomposition of ammonium nitrite, thermal decomposition of ammonium dichromate, ammonium nitrate thermal decomposition, ammonium dichromate thermal decomposition gives rise to which gas it is? Dinitrogen gas. Dinitrogen gas is non-toxic gas, odorless, colorless, tasteless gas. Dinitrogen is liberated when thermal decomposition of ammonium salts, ammonium nitrite or ammonium dichromate. On thermal decomposition, first your target is elimination of water. If the compounds are left, you should write the compounds like this, and what will be the product is, what the product we expect, that is dinitrogen. Dinitrogen will be the product from this equation. So make a note regarding these two preparations, make a notes regarding this dinitrogen. Thermal decomposition of ammonium nitrite, thermal decomposition of ammonium dichromate. Suppose if the compound is ammonium nitrate was given, suppose if the compound is if the reaction, once you consider this equation, NH4NO3 was given, thermal decomposition of ammonium nitrate, this compound is called as ammonium nitrate, NO3, NO3 is known as ammonium nitrate. What is our target? Our target is thermal decomposition target, removal of water. How many hydrogens? 4 hydrogens. 4 hydrogens required how many oxygens? 2 oxygen atoms. So eliminate 2 water molecules from this, eliminate 2 water molecules, remove H4, remove O2. What will be the remaining part? NO. NNO is called as what? N2O. N2O is known as nitrous oxide. Laughing gas, this is called as laughing gas. Laughing gas. It is also called as nitrous oxide, and it is also neutral oxide, and in this neutral oxide nitrogen oxidation number is +1 oxidation number. So make a note regarding this one, is very important compound, laughing gas. Molecular formula of laughing gas is N2O. Molecular formula of laughing gas is N2O. N2O is called as nitrous oxide. N2O is a neutral oxide. In N2O, nitrogen exhibit +1 oxidation state, and it is also called as laughing gas. How it is obtained? It is obtained by thermal decomposition of ammonium nitrate. So remember, thermal decomposition of ammonium nitrate liberate what gas it is? Laughing gas. Suppose the compound is ammonium nitrite, the answer is dinitrogen. So here once again you revise this equation number 1. What is equation number 1? NH4NO2. NH4NO2 on thermal decomposition, N2 gas plus 2H2O. While equation second one, NH4 taken twice, Cr2O7 on thermal decomposition, N2 gas plus Cr2O3 plus H2O. Dinitrogen from ammonium nitrite. Dinitrogen as a product from ammonium dichromate. Dinitrogen not a product from ammonium nitrate. Because of ammonium nitrate and thermal decomposition gives rise to laughing gas. What is the formula of laughing gas? Is N2O. These two are the suitable methods to preparation of dinitrogen. This is not a correct method to preparation of dinitrogen. So remember, which of the following is a suitable process to preparation of dinitrogen means we should give the priority. First is NH4NO2, not to first. NH4NO2 is right answer. NH4 taken twice, Cr2O7 also right answer. What is the wrong answer is NH4NO3. NH4NO3 is not used to the preparation of dinitrogen, and some more preparations also there, and that particular some more preparations are next preparation is very useful for competitive point of view examination. And here next one is from azide. Azide formula is N3 minus. Azide formula is N3 minus. This particular method is used to the preparation of ultra pure N2. Ultra pure N2. Ultra pure N2 can be prepared by using this method. The process is called as azide. This is very important competitive point of view question. Ultra pure dinitrogen can be obtained from azide. What azides? Azide number 1, already barium. Barium belongs to second group element. Azide formula N3 minus. Then the compound is, what is the compound is? BaN3 taken twice. This is known as barium azide, or sodium belongs to first group. Azide is minus. Then the compound is NaN3 is called as sodium azide. Thermal decomposition of barium azide. Thermal decomposition of sodium azide. Previous thermal decomposition, our target is removal of water. In this type of thermal decompositions, you should remove gases. What gas takes place in this example? N3. From N3 you should separate N2 gas. N2 gas you should remove. And what is the compound is? Ba plus N2. Here compound is Na plus N2. Ba plus N2 and Na plus N2. So, Ba plus N2, barium plus dinitrogen, here sodium plus dinitrogen. So this is a method to preparation of ultra pure dinitrogen can be obtained by using this method. Thermal decomposition of azide. Thermal decomposition of azide leads to the formation of what? Dinitrogen. Thermal decomposition of ammonium nitrite, dinitrogen. Thermal decomposition of ammonium dichromate, dinitrogen. Thermal decomposition of ammonium nitrate, not dinitrogen. From ammonium nitrate, we will get the compound is laughing gas. What is the formula of laughing gas is? N2O is laughing gas. Suppose if the question was given like this, don't get confused because of these reactions are interrelated. So don't get confused. Suppose the compound was given like this, NH4Cl plus NaNO2 gives rise to, we have to find the answer. What will be the answer? What we discussed regarding N2 discussion, N2 is non-toxic, N2 is odorless, colorless, tasteless, 78% is available in atmospheric air. It is also available in saltpeters, Indian saltpeter, chili saltpeter, KNO3, NaNO3. Thermal decomposition of nitrite gives rise to N2. Thermal decomposition of ammonium dichromate gives rise to N2. Thermal decomposition of azides also leads to formation of what gas? N2 gas. But what is the reaction here? Ammonium chloride untreated with sodium nitrite. Ammonium chloride is treated with sodium nitrite. Then eliminate this one. What will be the product is? NH4NO2 and NaCl. NH4NO2, already we know that NH4NO2 is called as ammonium nitrite, and ammonium nitrate thermal decomposition gives rise to the compound is N2 gas plus 2H2O. In NCERT you observe this equation. In NCERT textbook the equation was given like this only. To preparation of dinitrogen with respect to the ammonium chloride, this particular ammonium chloride is combined with sodium nitrite, then the compound is dinitrogen and 2 water molecules and formation of what is sodium chloride. And in this process some impurities we found, that is NO and HNO3. These are the impurities which are observed in this process, and these impurities can be removed by passing aqueous sulfuric acid in the presence of dichromate, sodium dichromate or potassium dichromate. So make a note for this one is very important. while preparing dinitrogen from ammonium chloride and sodium nitrite, preparing dinitrogen from ammonium chloride and sodium nitrite, dinitrogen is obtained as a gas by using this equation. Some impures, that is nitric oxide and nitric acid, it is nitric oxide, nitric acid are the impurities. How to remove the impurities means passing this products towards aqueous sulfuric acid in the presence of potassium or sodium dichromate. We should remove the impurities and we will get pure form of dinitrogen. And what is the suitable method? Ultra pure. Ultra pure is from azide. From azide we will get ultra pure dinitrogen. So this will be the preparations of dinitrogen. And still we have to discuss about the properties of dinitrogen. Dinitrogen undergoes which type of chemical reactions and what are the importance of dinitrogen. After completion of the dinitrogen, we should again discuss about the ammonia, how to prepare ammonia and what questions expect from ammonia regarding NEET or CET or JEE. We will discuss on next class. Stay with us. All the best. Have a nice day. Thank you.